Hello. Now we will calculate the capacitance of a spherical conductor. So since it's a conductor, so even if it is a shell or it's a solid conductor, both will have the same value. So what we will do, as we already know, to calculate the capacitance, we have to separate the charges. So I'll be putting the plus Q charge onto this spherical conductor. Okay. So when I'm putting a plus Q charge onto this conductor, the negative Q charge I'll be sending at infinity because the net charge should remain 0. There is no other body in the vicinity of this spherical conductor. Okay. So I've placed the plus Q charge, and as we already know about the properties of conductor, spherical conductor, so this plus Q charge will reside onto the surface of this conductor. And that distribution of this charge onto the spherical conductor will be uniform in nature. So since the charge is going to be at the surface and surface only, it doesn't matter whether this is a spherical shell or this is a solid body. Even the solid body, inside there will be solid, but the charge will only be at the surface. So if you look at the charge, charge will behave as if it's a shell. So this charge is distributed only at the surface. Okay, so now we have to calculate the capacitance for that, and we know the method. So when we are placing the charge onto the surface, the negative charge is going at the infinity. So the V minimum potential will be at the infinity, and the infinity we assume the potential to be 0. Okay, now as we move away from the infinity towards this spherical shell, the potential will keep increasing. And at the surface, the potential will be maximum. And as you go inside, since this is a conductor, inside the conductor, potential throughout is constant. So even at the surface or at the center of this spherical conductor, the potential will be same. So Vmax potential, maximum potential will be at the surface. That will be the potential at the surface. Now we have the formula to calculate this potential. So potential at the surface, we have a formula. So this body, for all outside points, this spherical body behaves as if all the charge is concentrated at the center of the sphere. Okay, that we understood, that we learned in case of electrostatic. So the surface, the potential will be from the formula 1/4 pi epsilon naught total charge upon the radius, that is r, since we are calculating at the surface. And if we move away from the surface, this r will convert into small r, where this small r will be the distance of the point with respect to center. Okay. So since V, voltage we define as the difference between the maximum potential and the minimum potential. And that value, since minimum is already 0, that will be equals to 1/4 pi epsilon naught Q by R. V. Or we can say Q by V will be equals to 4 pi epsilon naught times of R. Now we have a standard equation for capacitance. So standard equation is Q by V is equals to C. That's your standard equation. If you compare the standard equation with the equation we got in this case, on comparing, we will get capacitance to be equals to 4 pi epsilon naught times of R. Okay. So this is the capacitance for a spherical shell or spherical solid conducting body, obviously. So this is the capacitance. That formula one can memorize. Okay. Thank you.